To help achieve a carbon-neutral society, ENEOS is working on the development of production technologies for environmentally friendly synthetic fuels. Synthetic fuels are clean liquid fuels produced from CO2-free hydrogen and CO2 captured from industrial emissions and the atmosphere. As such, they are in the spotlight as carbon-neutral fuels, with the ability to minimize CO2 emissions across the product life cycle, from raw material production to product use. Synthetic fuels have three primary characteristics. First, they can be applied to existing forms of transport. As they can be handled in the same manner as conventional fuels, synthetic fuels can be applied to forms of transport where electrification and hydrogen use are difficult, such as with aircrafts, ships, and large automobiles. In addition, they can be used as a raw material for chemical products and lubricants, meaning that they can contribute to carbon neutrality across a broad range of industries. Second, they can be used with existing infrastructure. Synthetic fuels enable maximized use of existing infrastructure and distribution channels without the need to construct any new facilities. This means that they offer the advantage of minimizing the overall cost burden for society as we transition to a carbon-neutral society. Third, they offer resilience. Synthetic fuels are liquids and are thus capable of long-term storage, providing flexibility in areas and countries prone to natural disasters, like Japan. They also enable electricity produced from renewable energy, for which storage is difficult due to its generation being vulnerable to changes in weather, to be stored as a liquid fuel, thus allowing them to make a major contribution to a stable supply of energy. So, how are synthetic fuels made? Broadly speaking, there are three production processes. 1. Synthetic gas production. 2. Fischer-Tropsch synthesis. And 3. Upgrading. In the synthetic gas production process, a chemical reaction between CO2-free hydrogen and CO2 produces a synthetic gas composed mainly of hydrogen and carbon monoxide. In the subsequent Fischer-Tropsch synthesis process, a reaction is induced with a catalyst, and synthetic crude oil is produced. Synthetic crude oil has a wide variety of components, much like conventional crude oil, and thus can be considered an artificial crude oil. In the final upgrading process, synthetic crude oil is converted into synthetic fuels that conform to standards for gasoline, jet fuel, diesel fuel, heavy oil, and other such fuels. ENEOS is moving forward to develop the technologies to establish a production process that integrates all processes, from synthetic gas production to Fischer-Tropsch synthesis and upgrading. CO2-free hydrogen is a raw material for synthetic fuels and is produced using large volumes of renewable energy, meaning it costs more than conventional fuels. While the price of electricity derived from renewable energy needs to be kept down, it is also important to make raw materials into synthetic fuels without any waste in the production process. At ENEOS, we are working to develop the processes and catalysts that enable the highly efficient production of synthetic fuels. By taking advantage of the knowledge and know-how we have built up through our oil refining business. In developing these technologies, we are using the Fischer-Tropsch synthesis and upgrading technologies cultivated by the Nippon GTL Technology Research Association that ENEOS was once part of. We at ENEOS will contribute to the creation of a carbon-neutral society by working to establish technologies that will make the use of synthetic fuels a reality.